When Mo Farah is performing, the mechanisms of breathing is essential, as he will be needing to get oxygen to the working muscles, so will need to be taking in oxygen quickly to provide energy. Mo Farah's intense training program will make his alveoli stronger and more efficient, so this will help the breathing mechanisms when he is performing physical activity. Now we'll look at lung volume, which includes tidal volume, vital capacity, and residual volume. Your vital volume is the air inhaled and exhaled at each breath, and is the amount of air exhaled after the person takes a normal resting inspiration. Now your vital capacity is defined as the total amount of air that a person can inhale and exhale after a maximum inhalation. Your residual volume is the amount of air left in the alveoli in the lungs after a maximum exhalation. This residual inflation greatly reduces the amount of work required to completely re-inflate the lungs during the next cycle of inspiration. By adding both the vital capacity and the residual volume together, we obtain the total lung capacity. The equation for this would be vital capacity plus residual volume equals your total lung capacity. Mo Farah would have a larger lung volume as he is an elite athlete and does not smoke, for what we know, is not obese and is extremely fit. Also, if you live at a higher altitude, if you are tall and not obese, you have a larger capacity volume than others. This helps him as it can help get oxygen to the working muscles quicker and more efficiently, and he'll be able to exhale and inhale more in a minute, providing the muscles with energy. Control of breathing, neural and chemical. Neural controlling of breathing is when the brain controls breathing, which happens in the brainstem. For example, if the brain swells, the brainstem is pushed down into the neck area and is compressed, and this results in the cessation of breathing. However, atmospheric pressures also play a role as pressure in the lungs is lowered. The nervous system control of muscles used in respiration, including the diaphragm, is controlled by the brain. The rate of breath per minute is controlled by many factors, such as the acid-base balance, the pH of the blood, and this is a part of chemical control of breathing. The delivery of oxygen and nutrients. The blood vessels, which are arteries, veins, capillaries, are responsible for the delivery of oxygen and nutrients to the tissues, and the red blood cells, which are inside of these blood vessels, deliver the oxygen to the body by carrying it. Oxygen gets delivered to the body by pumping through its heart and lungs and going onto the capillaries to trade CO2 with oxygen. Nutrients get delivered to our body's cells the same way, except that food is involved. The delivery of oxygen and nutrients is important to Mo Farah, as while he is participating in physical activity, the muscles are working and need energy, and this is done by the delivery of oxygen, as oxygen to the working muscles provides them with more energy, decreases muscle fatigue, and also the build-up of lactic acid. Removal of waste products. There are four main options for removal of waste products, and this is called the excretory system. The lungs remove excess carbon dioxide, the liver breaks down proteins to produce urine and uric acid, the skin removes excess water, salt and uric acid, and the urinary system filters the blood to form urine. Removal of the waste product is important to an Olympic athlete like Mo Farah, because in order to inhale oxygen, he needs to exhale waste like carbon dioxide, for example, we'll use here, in order to get more oxygen to the working muscles to again give them energy to perform. The role of vasodilation and vasoconstriction of vessels. The role of vasodilation of the vessels is to increase the diameter of the blood vessels. This is caused by relaxation of smooth muscles within the wall of the vessels. When blood vessels dilate, the flow of the blood is increased due to a decrease in vascular resistance, therefore dilation of arterial blood vessels, mainly in the arterioles, decrease blood pressure. The function of this is to increase the blood flow in the body to the tissues that need it. Increasing the blood flow is important for Mo Farah while participating, as he wants to get oxygen to the working muscles as quickly as possible to provide them with more energy. Again, so it will help him work harder, will increase muscle fatigue, and also decrease the chance of lactic acid build-up too early in his performance. Vasoconstriction of the blood vessels is essential. Well, is essentially the opposite of vasodilation, where the blood vessels get narrower. When this happens, the blood flow is restricted and decreased, meaning the body can retain heat or increase vascular resistance. It is also important as after, for example, he finishes the race after performing physical activity, it needs his body to warm down. Like, for example, having a cool down to prevent muscle stiffness and fatigue by the buildup of lactic acid. Function of blood oxygen transport, clotting, fighting infection. Oxygen is transported to the tissues and lungs by red blood cells, which are stored in the blood vessels, and they come from the bone marrow, and after 7 days of maturing are released into the bloodstream. Red blood cells can change shape easily, which helps them fit in various blood vessels in the body. This is partly as they have no nucleus. This is extremely important when Mo Farah is participating, because oxygen needs to get to his working muscles to provide them with energy. Platelets help the blood clotting by gathering when an injury occurs, sticking to the lining of the injured blood vessel and forming a platform on which blood coagulation can occur. The blood clot covers the wound and prevents blood from leaking out. White blood cells protect the body from infection. There is one type called neutrophil that accounts for 55 to 70% of total white blood cell count. These cells only live less than 1 day, so your bone marrow must constantly make new neutrophils to maintain protection against infection. The other major type is lymphocytes, and there are also two main populations of these cells, one being T lymphocytes and B lymphocytes. T lymphocytes directly attack various infected cells and tumours. B lymphocytes make antibodies, which are protein that specifically targets bacteria, viruses, and other foreign materials. How does the blood transport through the body? As the heart beats, it pumps blood through a system of blood vessels called the circulatory system. The vessels are elastic tubes that carry blood to every part of the body. The three main vessels are the arteries, capillaries, and the veins, with the arteries taking the blood from the heart, the veins taking the blood back to the heart, and capillaries connect the arteries and veins, and as they are smaller and have thinner walls, therefore allows oxygen, nutrients, carbon dioxide, and waste products to pass to and from the tissue cells. Blood needs to be constantly flowing through the body at a fast speed for Mo Farah while participating, as his working muscles need to be getting oxygen through the blood system, providing with energy. On oxygen molecules through the respiratory system. When oxygen is first breathed in, it goes down the trachea into the lungs, and then to the alveoli inside the lungs. Then the oxygen molecule goes up into the capillary, while carbon dioxide goes into the lungs from the capillary. When the oxygen molecule is in the capillary, it is picked up by a red blood cell, which takes the oxygen molecule to the heart. From the heart, arteries then take the oxygen molecule to the muscle tissues, which need it to produce energy. After producing energy, the oxygen molecule gets broken into a carbon dioxide and is taken back to the lung by the capillary. It is important that as many oxygen molecules as possible is provided to the working muscles when Mo Farah is participating. This again is because he needs energy to his working muscles while participating. Thank you for watching, and I hope I taught you a lot on the respiratory system